Okay, hi, good afternoon.
Good afternoon, Miss.
Good afternoon, Miss.
Okay, there are still some people who are not here. Please inform them about our meeting, okay, if you have contact nila. Alright, so let's move on to our discussion to energy. Okay, alright, I noted. Thank you so much, Aaron. So energy, because energy takes many forms, there are only some of them that we can see or feel, right? So it is defined, usually energy is defined by its effect on matter. So for example, microwave ovens, they produce energy to cook food, but can you see that energy? Right? So we cannot see that energy. In contrast, the energy that is produced by a light bulb, when we switch it on, we can see that certain energy. So in this discussion, we describe the different forms of energy and discuss the relationship between energy, heat, and work. So energy can be defined as the capacity to supply heat or the capacity to do work. One type of work is the process of causing matter to move against an opposing force. Okay, your push or pull. So like matter, energy also comes in different types. So one scheme classifies energy into two types. So what are these two types? This is your potential energy, the energy of an object, um, the energy that an object has because of its relative position, composition, or condition. In physics, we also call this your stored energy. And another type would be your kinetic energy. So kinetic energy, from the word itself, kinetic, this is the energy that an object possesses because of its motion. So for instance, a battery has potential energy because the chemicals within it can produce electricity, which can consequently do work. Energy can be converted from one form to another, but all of the energy present before a change occurs always exists in some form after the change is completed. So, buddy, you just converted the whole energy to another kind of energy. This is what we call your law of conservation of energy. During a chemical or physical change, the law of conservation of energy states one cannot create and cannot destroy energy. It can only be changed in its form. This is also one version of the first law of thermodynamics. So I'm talking about kinetic energy. We have a kinetic energy that is associated with the random motion of atoms and molecules. That is what we call your thermal energy. Okay, thermal energy is again the kinetic energy associated with random motion of atoms and molecules. temperature, on the other hand, this is just a quantitative measure of how hot or how cold an object is. Okay, so when the atoms and molecules in an object are moving or vibrating quickly, we can say that they have higher average. I say average because you take the kinetic energy of each individual atom and each individual molecule. So when the atoms and molecules are moving quickly or they are vibrating quickly, we could say that they have a higher average kinetic energy. And we can say that the object is hot. Otherwise, when the atoms and molecules are moving slowly, they have lower average kinetic energy, and we call that object to be cold. So assuming that we don't have any other chemical reaction or phase change, when I say phase change, matter like from solid to liquid, liquid to gas, none. So if there are no chemical reaction or phase change, then if we increase the amount of thermal energy in a material, this will cause the temperature to increase. Okay? And vice versa, assuming again mawalay condensation or freezing that occurs if we decrease the amount of thermal energy in a sample of matter, then it will cause the temperature to decrease. Okay? So what do we call the transfer of thermal energy? We call it your heat. Heat is denoted small letter Q. So heat is the transfer of thermal energy between two bodies at different temperatures. Heat flow increases the thermal energy of one body and decreases the thermal energy of the other. So for example, I have one body which has high temperature, let's call this body H, and one body that has low temperature. So we will call it substance L. Okay, so for example, initially the atoms and molecules in H. Okay, so initially atoms and molecules of H, let's separate first. Let's separate them from each other first. Okay, so again, we have substance H and substance L. So initially, ang imuhang substance H has higher temperature, thus high iyahang thermal energy, while your substance L has low temperature and low thermal energy. Okay, the atoms and molecules in H then have higher kinetic energy than the atoms and molecules in the substance L. What if we put substance H and L close together? So this would be H, this would be L. If we place substance H in contact with substance L, the thermal energy will flow spontaneously gikan sa higher thermal energy towards the lower thermal energy. So for this case, H has higher thermal energy, so it will flow from H to L, ang imuhang thermal energy. The temperature of substance H, because of this, will decrease, while the temperature of substance L will increase because of the flow of the thermal energy. Okay. Heat, the heat flow, it will continue until the two substances are at the same temperature. Okay. Or we call this the thermal equilibrium. As long as dili pa equal ilang temperature, then thermal energy or heat will flow continuously or spontaneously from substance H to L until same na sila og temperature, which we call our thermal equilibrium. So thermal equilibrium is when both substances are at the same temperature and their molecules already have the same average kinetic energy. So energy units, let's talk about the units used for energy. Matter undergoing chemical reactions and physical changes, we know that they can either release or absorb heat. So from here, ang imong H ga-release og heat, while ang imong L ga-absorb og heat. So we call this, we also have these terms for these processes. So a change that releases heat, that is called an exothermic process. While a reaction or change that absorbs heat, we call that endothermic process. Historically, energy, ang first unit sa energy is in terms of calories. Okay? Calories or simply cal. So 1 calorie, a calorie is the amount of energy raised to raised 1 gram of water by 1 degree centigrade. Okay, so if you are able to raise 1 gram of water by 1 degree centigrade, ang energy required para ma-raise siya into 1 degree centigrade is called 1 calorie. However, this quantity, kaning a calorie, it depends on the atmospheric pressure and the starting temperature of the water as well. So the ease of measurement of energy changes in calories meant that calorie is still frequently used. So you can also find calorie kanang sa luyo sa inyong mga food products, sa inyong mga food content. So you can find calories in quantifying food energy content. However, we have our international system unit that is not dependent on the atmospheric pressure or anything. So the SI unit of heat, work, and energy is joule, or simply capital letter J. So this is defined as the amount of energy used when a force of 1 Newton moves an object of 1 meter. Okay, so I don't know if you have this in your physics, but work sa physics is defined as when you exert a force on a certain object, and when you displace that object, you call it that means that you do work on the object. If dili mo move ang object, then there is no work. So that's why 1 joule is equal to 1 Newton meter. This joule, kaninga term nga joule, this is named in honor of the English physicist James Prescott Joule. So I hope you know that 1 Newton is equivalent to 1 kilogram meter squared per second squared. That's why 1 joule is also called 1 Newton meter. And to standardize its definition, 1 calorie is equal to 4.184 joules. Okay? Now, we introduce 2 concepts that are useful in describing the heat flow and your temperature change. So one is your heat capacity. Heat capacity is denoted as capital letter C. The heat capacity of a body of matter is the quantity of heat it absorbs or releases when it experiences a temperature change of 1 degree Celsius or maybe 1 Kelvin. So mathematically, your heat capacity can be expressed as C is equal to Q over delta T. So Q is the heat, delta T is the temperature change. Heat capacity can be determined by both the type and the amount of substance that will absorb or release heat. And since it is dependent sa amount mismo sa substance, it is referred as an extensive property. Or when your property is proportional to the amount of the substance. There is also another quantity which we call the specific heat capacity. Specific heat capacity is denoted as small letter C. Okay? It is also commonly called as specific heat. And it is the quantity of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius or 1 Kelvin. So mathematically, specific heat capacity is expressed as C to the heat per mass times delta T. In contrast sa heat capacity, your specific heat capacity depends only on the kind of substance absorbing or releasing heat. But dili siya dependent sa amount of substance. It depends only on the type of substance. That's why we call it an intensive property. The molar heat capacity, which you can encounter also sa chemistry, your molar heat capacity is also an intensive property because your molar heat capacity is simply the heat capacity per mole of a particular substance. Okay, so C per mole. And the unit is joules per mole degree Celsius. Okay, so now we also listed the specific heat values of some. Okay, so this is the table that lists the specific heat values of air, aluminum, copper, and so on and so forth. If we know the mass of a substance and its specific heat, okay, we can determine the amount of heat entering or leaving the substance by measuring the temperature change before and after the heat is gained or lost. So if we rearrange this equation kani sa inyong specific heat capacity, we will find that Q is equal to specific heat times the mass of substance times the temperature change or delta T. So bali imong delta T is equal to the final temperature minus the initial temperature. So this is the specific heat of the substance again. M is your mass and delta T is the temperature change. So if a substance gains thermal energy, we know that its temperature increases. And what happens? So if ever gain thermal energy. So temperature increases, that means T final is greater than T initial. So imuhang delta T is positive, that would make your Q positive. What about if it loses thermal energy? So if it loses thermal energy, then its temperature decreases. That means your T final will be lower than your T initial. And that would make your delta T negative. Consequently, that makes your heat negative. Okay, and the value of your Q is now negative. So let's try solving a problem regarding energy. Okay, so this is the problem. Okay. A flask containing 8 times 10 squared grams of water is heated, and the temperature of the water increases from 21 degrees Celsius to 25 degrees Celsius. How much heat did the water absorb? So going back sa atong formula, Q is equal to Cm delta T. Q is equal to Cm delta T. List down the quantities. C, it says water, unsay specific heat sa ato ang water. Here, it says the specific heat is 4.187. Okay? So 4.187. Unsa man ni siya? Joule per kilogram degrees Celsius. Oh, this is joule per gram class, okay, not joule per kilogram. So that is joule per gram degrees Celsius. We also have the mass of water for this case is 8 times 10 squared. So that is just 800 grams of water. And your delta T is, you have your final and initial temperature here. Delta T is 85 degrees Celsius minus 21 degrees Celsius, which is equal to 64 degrees Celsius. Simply substitute these quantities. Q then is equal to 4.187 joule per gram degrees Celsius times 800 grams times 64 degrees Celsius. So the value of your Q is equal to around 210,000 joules. Because the temperature increased, the water absorbed heat, and we determined that your Q is positive. All right, so far, any questions? Okay, thank you so much sa response. Let me upload this sa inyong Canvas. Wait for a while. Okay, so as you can see sa inyong Canvas, I already uploaded legible handouts regarding this discussion. For the rest of the time, I want you to see the page on notes for thermochemistry and be familiarized with how to solve some thermochemical nga mga problems. Okay? Naad na answer key dira, so no need nga magkuan-kuan mo sa inyong internet. So this is just for you to utilize the rest of your time. Okay? So I guess if there are no other questions and concerns, I think that's it. And thank you so much for attending this meeting, and see you next week. Bye.
Goodbye, Miss.
Goodbye, thank you,
Goodbye,
Miss.
thank you, miss.
Bye, Miss.
Thank you, miss.
Bye, miss.